This is a query processing architecture module, and in this video we will discuss about the weight types. So we will discuss about what are the weight statistics and for what purpose these weight statistics are used in our server. So weight statistics are the important these performance tuning metrics which are the numbers. We will use these numbers to track and troubleshoot the performance either at the instance level or for a particular query. So now first going to troubleshoot to use these weights, we first have to define our scope. That our scope is at the instance level. For example, if we have an ERP and many users from this ERP many users from different departments are using this ERP and they are connected with the database, and now they start complaining about the slowness of the server. So then our area for scope of the area will be the instance level. So we have to concentrate on the instance level and check the weight types on the instance level. If a particular user from this any department, for example from inventory department, the one user is printing the cost related to the items, and he start complaining that before this report was working well now, but now it's very slow. So then we have to consider only on that area which is related to that module. For that report we have to concentrate only on the this particular query. So there are the two scopes. We have to either on the instance level or either on a particular query which is related to that particular user which is complaining about the slowness of the system. So we have to define our scope of for troubleshooting like this one. So let's move. First we will check that all the users from all the departments are complaining about the slowness of the server. So we will check the weight types at the instance level. We will see how to use these weight types to monitor the health of the server. So let's move to the SQL Server Management Studio. This is the SQL Server Management Studio and we are in the query analyzer. So I have here a DMV sys.dm underscore os underscore weight underscore states. So with this DMV will give us all the weight statistics which will occur on the our server. So there are a lot of weights it will give us, but all the weights are not problem creating weights. There are a lot of weights which will be recorded by the server, but these are the innocent weights. The most problem creating weights I will filter from this DMV. This is the script which I copied from a website on the internet. This is the website name. I copied from here, and I'm using as it is with filtration of the sum weight, because these are the some weights which are the most problem creating when these weights occurs on the system, and they are some high in the numbers. So we have to focus on these weights. We have to check the performance of our server. What are the reasons? Because this weight type will give us sufficient information to to find the problem and then to define the solution for that problem. So let's execute this script which will give us the weight types and the times of the weight. These are the name of the weights, and this is the time in seconds, like this weight occurred in the system for this much seconds, and this is the percentage of the weight occurring on the server. So if the this time right now is only this weight is has some little more time, but these are not is not reasonable. Is reasonable this time, but this time sometimes is in the odds. For example, now this 1010 seconds times mean this is only occurred for 16 seconds. So now why this weight occurred? What is the cause of these weights to be occurred on our server? Let's discuss that. The IO completion weight type, when this wait type is recorded by our server, then it means that, and we have to check the time is very high, percentage is high, more than this 50%. It means there is some problem with some query. The queries are very extracting very large data, and the data taking time to be extracted from the storage device. For example, I'm using this query. This query is using the cross join, and there are two tables involved, and this table have more than 100 records. So when this cross join will happen, it will go into the millions. For example, if I'm going to check how many records are in this table after cross join, so there are 12 million records. So to extract this much big data, it will take time, and then it will that this wait will be recorded by the SQL server. And if this is very common, that it's taking this time too much, and this is very common scenarios that users are extracting this much data, then we have to check why this we actually we need, or we don't need. Maybe the query is not written well, and so we have to check first the query. We have to rewrite the queries. We have to check the indexes on the tables, it's working properly or not. Or if the table is very big, so we have to partition the table. So there are the different ways to troubleshoot this problem. But first of that is this wait, this DMV will give us the this is really this is the problem or not. So we get the useful information, because now this happened and this take for 16 seconds because I executed this query, and then I stopped this query because it's taking time, and during that time it's recorded this much time, 16 minutes. So for that we have to rewrite the query. This is the number one reason. And the second reason, maybe the storage is very slow. Store the data, our database file, MDF file, is on a external device, on some disk, on some SAN disk, and this disk is responding slowly. So in that case, this is not related to our SQL server. This is related to the network. For example, this is if I will this is our SQL server. This is the SQL server, and here is the storage device. Some device is here. So in this, between this device, there is an intermediate devices also. These are some switches. So this is the storage, and the server will go through this to extract the data. And the second reason for IO completion wait type is because of this one or because of this one. So it's related to the networks. So if our query is accurate, there is no problem with the server, then we have to contact with the network administrator. Please check the network. Either the storage is not working, responding very slowly, or check your devices which are in between the server and the device. So you this is the area of the network administrators. The administrators, we don't have any problem on the server. So this is the second reason for the this wait type to occur. And now there is another wait type which can occur, which is a common wait type, page latch. So this wait time will occur only on that time when we have the there are the there are the different there is a one task is executing, one thread is executing, and this thread is waiting for one page. There is these have the pages. This page need to be read into the memory, and this thread is waiting. But this there are the memory is not enough. There is no memory, no memory. It's all are busy. All other threads are busy. So this thread is still waiting one for the one page to be read into the memory, and don't have the sufficient memory. So in this wait time, this page latch wait will occur. Page latch wait will be recorded by the system. So in this case, we have to check our memory. We have to increase the hardware to increase the hardware, so that there should be the sufficient memory. And there is a very important weight type, CX packet, which is a very common weight type. If right now this is only a 16%, but if it is more than 50%, that this will we should have to consider why this taking too much time. The 6x packet is related to the parallel processing. When we have a one query, we have submitted one query. For example, this is a query. Select B name supplier item from products to join product supplier B on A dot supplier code is equal to B the supplier code. When we have submitted this query, the server will think that server will submit to the this when this query optimizer will prepare the plan. And query optimizer, when prepare the plan, it's considers the cost of each operator in the plan. So there are two operators. One is a serialized operator, serialized, and one is the parallel operator. So when the workload is submitted to the optimizer, this is the optimizer. Workload is going to the optimizer, and optimizer think that serialized cost is suppose parallelized cost, for example, is 25. Serialized cost is 30. So optimizer will consider the cost, and the operator which is lower cost optimizer will select that operator. So it selected that parallel operator. But actually the query which is submitted, the workload is not that much enough. For example, parallel processing, if workload is greater, is a very big, in that case the parallel processing is fine. But if the workload is small workload, for example there are only 100 records in the system retrieved by the query, so in that case no need parallelism, because parallelism will distribute the workload into different threads, and then these threads will be executed on different for different processors, and to distribute these threads and to collect the data from these threads will take the time. So this will make the process to slow, and the slowness will be recorded by the CX packet wait type, that this much time is taking by this parallel processing. And this time, this time may be greater than this. For example, this all to execute all these 100 records parallelly, it's taking maybe the 40. This is any number which will be created by the system, by the optimizer. It will consider that this 40 is greater than 30, and but when it's optimized, that time it's find that the 25 is the parallel processing time. This 25 is taken from the SQL Server configurations, and when it's calculated the serialized time, it's 30, it's greater than 25. So the parallel plan is chosen. But actually when the query is executed using the parallel plan, it's taking more time than this serialized. So if this is the very common, this occurring with most of the queries. In that case, the solution is that we have to go to the our SQL Server, and here we have this is the instance of SQL Server. In this instance level properties, we can go here in the properties, and in the advanced, here is the parallel processing. This is the parallel. Here we can increase the cost, that not 25, when this cost will be the 30. So optimizer will check now if the cost for the other operator is greater than 30, then it will consider this parallel processing. So we have to change this number very carefully, because it will affect the performance of the system. And if this is the problem with not all the query, with only particular query, only a particular query will takes this CX packet, it's only the CX packet is recording with the high number only with this query suppose. So in that case we have to use DOP. This while compiling this query, we can force this query to use the paral don't use the parallel processing. Degree of parallelism is one, that only one processor to use. So we can solve like this problem. So if the problem is with all the queries, with most of the queries, then we can change the configuration at server level. And if this is a problem with only certain query, then with this certain query we can force this query to use only one processor. So we can solve the CX packet problem by using these techniques. And there are some other void types which are we noted here. These are the SOS scheduler. SOS scheduler is also a common wait type, which when we execute this DMV, we can find that this is also happening on the server. So this is normally showing, this SOS scheduler is showing that it's there is a pressure on the CPU. So CPU has there are the multiple sessions are opened. For example, I have used this query which have 12 million records, and I executed this query with multiple sessions. So now this query will create a wait type SOS scheduler which will show that there is a pressure on the CPU. So if this number is high, we have to see where the which then we have to troubleshoot which queries are creating pressure, which so we have to check concentrate on these those queries. And this asynchronous IO completion, this is also